Hi all, I hope you all are doing fine. So today I am going to explain about MLPerf and how you can do an MLPerf inference submission. So first, what is MLPerf? So if you go through the given link by NVIDIA, you can see more details of it. But in short, MLPerf is a benchmark suite for machine learning, and it is made by a consortium ML Commons, which is formed by many large companies like Google, Meta, NVIDIA, etc. So, or like in short, any ML company is a part of it. And the aim of ML Commons is to showcase like which hardware or which software is best suited for each machine learning task. And MLPerf inference is one of the working group of ML Commons. So ML Commons have different working groups like one for training, for data set, for machine learning algorithm, etc. And inference is one of them. And we have inference submissions 2 times a year. And the next deadline is on March 3rd. So now a short description about how an MLPerf submission looks like. So there are two main categories for submission. One is edge and one is data center. So you can see, imagine edge to be like a small device, which can be, for example, a Raspberry Pi, to even like a tiny server, which is handling like queries from edge devices like mobile. And data center is like what you can expect in a big data center or a large server. And we have two links here which shows the last round inference results. So you can see the results of companies like NVIDIA, Qualcomm, etc. So now you might wonder like, okay, I'm just doing BTech, and how can I do MLPerf submission in such a short time? Like we hardly have 3 weeks left. But the interesting thing is that to run each benchmark, it usually takes only 30 minutes because we have one accuracy run and one performance run. So the performance run needs to be minimum 10 minutes, and usually even the maximum is 10 to 15 minutes. And the accuracy run, it depends. Sometimes it takes 5 minutes, but on a like small device like Raspberry Pi, it can take 20-25 minutes. So we had a recent conference of supercomputing where 11 out of 14 student groups, they managed to make an MLPerf submission, and all they had was 30 to 60 minutes. And it was interesting. And basically they had a reduced run, means they were not running the whole data set of images or whole number of required number of queries, but even then the whole setup of the benchmark they were able to run. So this shows that you can also do it, and in a very short amount of time. So now a little bit about CK. CK stands for collective knowledge and CM stands for collective mind. So basically CM is, you can say, a new version of CK. So CK is an automation framework which has multiple use cases, and you can imagine like it can be used to automate many tasks, and inference benchmark is one of those tasks. So actually, I started using CK almost 2 years back, and from the start itself, I like the concept and how it makes life easy as an engineer. So I was very fascinated by it, and last year, April onwards, I was fortunate to work on CM from scratch. So it is a redesign of the original CK tool from scratch. So since I was involved from the beginning, you can say it is my another baby like Gate Overflow. So what we have in CM is like we have script. So by script, you might think like, okay, it's Bash script or Shell script. But actually, it can be anything. It can be Python script. It can even be like a C program, C++ program, or anything. Any program which run, we consider it like a script. And the scripts are having metadata also. Like So what the script is doing or what is the purpose of it, we use like metadata with which are indexed using tags. So basically when you say like get dataset image classification, so then we get all the data sets which are for the image classification task. In a way, like this is similar to how the tags work anywhere like in Stack Overflow or Gate Overflow. So now it's the metadata is actually more powerful than just the tags, because we have basically the CK or CM uh, is mainly developed by Grigori, and he has more than 10-15 years of experience in this area. So like all his experience has been put into this framework. So like we have handled many of the complex cases which you might not understand now, but when you start running or using the tool, you can see like how powerful it is. Now, if you are thinking how to start, like unfortunately or fortunately, we don't have any like tutorial or more description on this, but you can start using, and then we will see like how it goes. And we actually have a, GUI, which the link is given here. So what it does is yeah. So you can see like this basically the final output is the important one. So you get the command here. So if you copy paste this command on the terminal, you basically get an inference run. And before that, you have to do this like install the cmind Python package and pull these repos. Just two commands, and after that, copy paste this, and you will get the inference running. And these parameters are for customizing the run. So I would say like you need to do two things. One is the mode find performance, and we have another MLPerf mode, which is you can do accuracy mode or performance mode. I would say performance is the one which should go with fine performance. So what fine performance does is it does a short run, and it will say like what is the latency or throughput on your machine. And once you have the performance metric, then all modes, this is the all the modes which are needed by MLPerf. Okay, so now if you think, okay, just running the benchmark, is it all? No, we have the real interesting part coming. So that is the performance measurements or improvements. Like when you run the benchmark, you get a performance number, and now now the task is how you can improve it. So and we have actually two types of task here. So I would say like the first part is for those who like systems. So if you are not sure like what system means, you can say like in the bachelor's, if you like the subjects like operating system, computer organization, or even computer networks, those are the system subjects. So and even C++, because those languages are used on the system side. The first part of these assignments, I would say, are more for those who like systems, and there are other people who are like say more interested on the algorithm side or machine learning side, or mathematics or Python side. So those people, we have another set of interesting tasks towards the end. So first, let me go through the system side part. Yeah. So to do these measurements, you have to do the cmind installation and pull the repo. And yeah, so we have a script here. So if you, after pulling the ml comments at ck repo, you can just run this script. So the local file location will be this. So just python 3 run underscore mobilenet dot py, that you should do first, because when you do that, it will do a test run. We have 81 models in this script, So all those models will be run, and so this is a short run. So it should not take more than 30 minutes, and after 30 minutes, it will show the performance of all the 81 models. So this is a test performance only, and after this is done, then that is the real performance run. So there again, this command followed by the submission option. But I forgot to add here, to do the actual submission, you need a full data set, which unfortunately is not public, but uh, I can share it. Maybe you can ping me in the Discord channel, which the link will be shared later. But yeah, the data set is not public, but you are allowed to use because every submitter uses it for the submission. And this script is actually using TensorFlow Lite backend. So we have, maybe you might not be aware of the different backends in the machine learning area, but TensorFlow, PyTorch, ONX runtime, these are the common ones. And TensorFlow Lite is a light version of TensorFlow. Again, if you think, okay, just this is another script and you are just running it. So what is the challenge there? Yeah, so far it seems pretty simple, but again, the how you can improve the performance. So for the script which I described, sorry, there was some issue and it got disconnected. So yeah. So now how can you improve the performance? So in the above script, the only parameter is, I can say, is number of threads. So the number of threads is basically telling how many like logical cores on your CPU the application can use. So you might think that, okay, I will use all the cores and I will get the maximum performance. So you can try it. You can try from 1 to the total number of cores. It can be 4, 8, 16, whatever, and see like whether the performance is going up, and is it the same for all the different models. And the next task is for adding CUDA support. So some of you might be familiar with CUDA, and if you have an NVIDIA GPU on your laptop or desktop, you can actually run machine learning models on them. And typically the performance there will be much better than running on the CPU. But the interesting or the challenge here is that the code which is used here for our benchmark, that is the last one here, it is not having support for CUDA. But if you can see the example here in this link, and you can try to add the CUDA support. And another thing is that we have actually three different scenarios in MLPerf inference. So one is the single stream, then we have multi-stream, and then we have offline. So you might already be familiar with the terms like latency, throughput, etc. I think it is there in network, computer networks also. So it's the same here. Like latency means like I gave an query or like image which should be classified. So from the time I gave it, and from the to the time when I get the result back, so that the time delay, that is called the latency. So yeah, and now the throughput is, you can say, in simple terms, it is 1 by latency, but that is true only if we have one input at a time. We can have like 1,000 input at a time, and if we are processing all of them together, then it will be that number, the time to process all of them divided by 1,000. So it's similar to the bandwidth term. So currently we have the implementation for single stream, but the offline implementation is not there. So this, the first link here is having an another implementation where offline and single stream are done. So you can give a try to add that offline implementation to this code, which is for TF Lite. Okay, so now we can talk about those or assignments to those who don't like C++. So those are the Python people. So one task which you can do is like there are thousands of models out there, and we can add new models to inference. But again, we cannot add any random model because uh, MLPerf requires that they have six benchmarks, and six benchmarks use six different data set. So we can use any model as long as that model is trained on the same data set which is used for these six tasks. So out of these six tasks, what we think is the most easy one is the language processing, and BERT model is the one used there, and it is trained on SCORE v1.1 dataset. So basically, you can go to a places like Hugging Face and pick any model which is trained on SCORE v1.1 dataset, and then it needs to be added into our set of CM scripts. So I have added a link here, which is for like a sample script, which downloads from one like a model zoo called Neural Magic. So the zoo means it's a collection of models, and from where others can pick the model and use it for their task. So Hugging Face is another place where you can get such kind of models. Okay, so now another interesting, which I would say is the most interesting task and most challenging, is PyTorch 2.0. So the current latest version of PyTorch is, I think, 1.13, and the next one is 2.0, and which is not yet officially released. It is in the development stage, and it is going to be released in few weeks. So the main difference there is they are adding an option to compile models, and the performance should be much better. So it would be very interesting if you can run the models, which can be any model, like the models which are already in the CM repository or which you are adding from Hugging Face or anywhere, and try it on this PyTorch 2.0. But to before that, like you might not be knowing how to use PyTorch 2.0 because it is not yet added to our CM framework. But don't worry, that we will be doing within a couple of days. We will be adding this 2.0 into our CM framework. So after that, it will be very easy for you to use it. Okay, now like I just gave an overview. I am sure that you will have plenty of questions, and when you start using, there will be more questions. So don't worry about that. CM is still it is stable, like relatively stable, but it is still in development stage. Like if you see, like every day we have 5 to 10 commits at least. So there will be issues, and there will be things which are not completely implemented. So if you face any issue, like you are not able to go forward, just raise an GitHub issue, and this is the link for that. And regarding running the benchmark or having a doubt or clarification on how to proceed, we have a Discord channel, and the link is here. But please be aware that this channel is open to like everyone all around the world. So we have people there from different places like US, China, and students from and there are also students from Russia and all. So yeah, it's an opportunity for you to see like how international students work. Okay, so this is an image. Yeah, so it shows that my expectation is at least 10 of you will be having great submissions, and hundreds of you should be at least able to run all these benchmarks. So this is open to not just the students because we are working as an for the community. CK is open to everyone, and it is free to use. There is no license issue or anything. It's completely owned by MLPerf organization, and we are going to do this submission through CE Knowledge again, which is another non-profit organization. So whether you are working for any company, or you are studying, or you are not doing anything, you all can participate here. It's about, there is nothing like the end thing for this task. Like, as you can see, there are a lot of things to do. You don't need to do everything. Even just running the benchmark, that itself is a good start. Okay, so that's all from me now. I hope, so this first image is for disappointment, and the second one is for excitement. So I hope you will make me excited. So that's all. Bye.